Welcome back, statistics scholars. Today we're going to be learning how to use PSPP to do one sample and independent samples t-tests. As a reminder, PSPP is the open source version of the proprietary IBM software SPSS. And as a reminder, in PSPP we have variables, which are ways that people or anything else you care to observe can be different, and those are the columns. And then along the rows are the individual observations that you've made. For example, here I have this person 3 who was 80 inches and 160 pounds. And up to this point, we have seen this analyze option a lot. And then also last time, we learned how to use the transform option. But today, we're going to be right back under analyze because we're going to learn to do a one sample t-test in PSPP as well as an independent samples t-test in PSPP. As a reminder, a one sample t-test is when you have one sample of data that you're going to compare to some known or comparison value. For example, if I know that the average extroversion score in the United States is 50, say I know that ahead of time, and I wonder if college students have higher extroversion, I might collect one sample of college students and compare that one sample data's average to that known value. It would be a one sample approach. An independent samples t-test, on the other hand, is when you don't have a known value to compare your one sample to. So instead, you're going to get two samples of data and compare them to each other, where the assumption going in is that there's no differences between the groups, and you're hoping to find evidence that in fact the groups are different. And that's what's called the null hypothesis significance testing approach. If you're interested in learning all about null hypothesis significance testing, I recommend you watch my actual substantive statistics videos, where there's one entitled One Sample T-Test, and of course independent samples t-test as well. This video is just how to learn the mechanics of PSPP, assuming you already know conceptually what a one sample t-test and an independent samples t-test, what those analyses are already. So to begin, let's do a one sample t-test in PSPP. We're going to click Analyze, and then what you're going to see is this drop-down menu pop up, and all of the analyses that compare averages are grouped together under compare means. So here we have one sample t-test, independent samples t-test, paired samples t-test, and what's called a simple one-way ANOVA. So here we're going to click one sample t-test, and this pop-up window is going to be shown. And here you have your variables here on the left, and because it's a one sample t-test, we only need to choose a single variable, the one sort of sample of data that we want to look at. So in this case, why don't we explore the age variable? I want to know, let's say ahead of time, I want to know if Pierce College students, are they older than students in general across the United States? And I happen to know that the average age of college students across the United States is 22 years old. I went ahead and looked that up. So now I have a comparison value to then compare my one sample to. So I get one sample of students from Pierce College, and I compare them to that known value of 22. So down here then, I'm going to choose the age variable over here. And again, from last time we learned how to right click and look at just the names, but age is right there first. What is your age? So I'm going to toggle that over here. So here we have that age variable under test variable, because that's what I'm testing. I'm testing to see if age is different in my one sample compared to that known population. So this one sample of age data, I'm going to compare it to that known value of 22. So I type 22 into here, and I just toggle age from to the left all the way to the right using this little arrow here. And then I'm just going to click OK. And that's going to pop up this output here. And here's how to interpret this output. So what is your age? It's reminding me of the one sample that I grabbed. N is going to be the total number of responses that I have. So 56 people answered this question. The mean for my one sample was 23.75 with a standard deviation of 9.19. The standard error for this analysis was 1.23, which in this case would have been S over the square root of N. And so the t-statistic the one sample t-statistic for 55 degrees of freedom was 1.43. And then the significance, two-tailed, was 0.160. Now, you get to choose your alpha. You get to choose your alpha, remember, but by convention, most of the time alphas are 0.05, and so 0.16 is larger than 0.05. It also gives me automatically the confidence interval for the difference, so negative 0.71 to 4.21, which this does contain 0, and so this would then be a failure to reject the null. The p-value is greater than 0.16, and this does in fact contain 0, which in this case is the interval of the mean difference between 22 and 23.75. So that mean difference is what PSPP constructed the confidence interval around. And again, if you want to know more about confidence intervals, I recommend you watch my substantive video entitled Confidence Intervals. Again, this is just to learn how to use PSPP. So not only does it do the t-test for us, but it also gives us the confidence interval. And so so we would fail to reject the null hypothesis because our p is greater than alpha, and our confidence interval contains the null value for the mean difference, which is 0. If we cruise down here to the independent samples t-test, we can also learn how to use PSPP to analyze data to do an independent samples t-test. Now again, this is when you don't have a specific number you want to compare your data to. So we're going to then have two samples of data and compare them to each other, where again the null hypothesis would say there's no difference between them. So those who've been following along, in our last video, the guide to PSPP 5, we actually learned to recode a string variable into a numerical group-based variable. And it's important to have a numerical group-based variable in order to use PSPP to do an independent samples t-test. So if you have a set of data where someone has told you about their group status, like for example, I want to know if students who have a job have a higher GPA compared to students who don't have a job, or are they just different? I'm just curious. I'm curious if students who have a job have a different GPA compared to students who don't. Notice I have two variables there. I have whether or not students have a job, and then also I've asked students their GPA. GPA is a quantitative variable where the numbers have value. Somebody with a GPA of 3.5 has more of something than compared to someone with a GPA of 3.1 or 2.7. So this is what we call a quantitative variable, but whether or not someone has a job is a qualitative nominal variable. And in PSPP, when I originally asked the question, I let people give me a free response. I let them answer anything they wanted. They could say, yes, I have a job. They could tell me I'm a waitress. I wanted to give people the freedom to type in any response they want about their job. And so last time in the guide to PSPP 5, we learned how to recode those word-based string variables that may represent a qualitative variable. We learned to recode them into numerical placeholder variables that PSPP can then use to analyze. So this PSPP guide assumes you already have done that and you're working with a group-based qualitative variable that has been recoded into those numerical placeholder values. So here we go, compare means, and this time I'm going to click compare means, and this time I'm going to choose independent samples t-test as opposed to one sample t-test. So I'm going to choose independent samples t-test, and you'll see this pop-up window. It's similar to the one sample t-test, where we're still going to have the test variable. This time we're going to be choosing GPA because I'm curious if these two groups differ on GPA. But instead of having a specific number that I'm going to compare my one sample to, I now have a grouping variable, a qualitative group-based variable that I'm going to compare the two groups to each other. So I'm going to, again, pull GPA over into the test variable using this little arrow, but then I must have already had or created a grouping variable that where the groups are defined by numbers. Again, the numbers don't mean more of something, the numbers are just placeholders. And what I have done is I've created a grouping variable for whether or not students have a job. I've done that already. And again, if you want to know how to do that, you'll need to go watch a guide to PSPP 5, but I've already done that. So I choose the grouping variable, and again, I move it from the left to the right, but then I need to define the groups. It won't let me press OK, it won't let me run the analysis until I tell PSPP which numbers to look out for. So I do that. I click here, define the groups, and what I used was a dummy code. When I created my job RC recoded variable, anyone who told me that they didn't have a job, however they told it to me, I gave them a zero. And then any person who told me that they had a job, whether they said yes, they had a job, or they told me specifically what job they had, I gave them a 1. And so I then have a series of zeros and ones in my data set. And again, this is what's called a dummy code. And so I tell PSPP that that's what defines these two groups. One group has zeros and the other group has 1. And then I get to click continue. And now, once I've done that, I'll be able to click the OK. That will be available to me. And then this output will pop out. It's going to then show me that I have 16 people who told me that they didn't have a job. So I would call this baby N. Baby N, so 16 people. So the subgroup sample size for among all of my people who responded in my survey, the subgroup sample size for the people without a job is 16. And then over here, the subgroup sample size for the students who did have a job were 37. So most of my students, in fact, report having a job. And if we peek over here at the means, we can actually see that those students who don't have a job have a higher GPA compared to those students who do, at least on average. And these, of course, are the two standard deviations. So let's see if this is a statistically significant relationship. This is what's called the Levene's test for the equality of variances. We're not going to look at this for now. If you're interested in this analysis, you would go ahead and watch my t-test, independent samples t-test lecture video. For now, we're just going to focus on the t-test itself, which is right here. Here we have t for 51 degrees of freedom is 2.74, and this is the p-value here. And as we can see, the p-value is equal to 0.008. And if we were using an alpha of 0.05, this alpha would in fact be higher. This alpha would in fact be higher. Excuse me, the alpha would be higher than the p-value. The p-value is smaller. Small p's mean we reject the null hypothesis, because what a small p-value indicates is that there's a low probability that we're seeing this data, these means, simply due to chance. Because that's what a p-value is. The probability of data like ours, if we first assume the null is true. And the null always says that any mean differences are simply due to chance, random chance. So the p-value then represents the probability you would have seen a mean difference just like this, simply due to what we call sampling error, simply due to what we would call random probability, that the null is true. And so then there is a less than 1% chance that we saw a data split like this, right? A mean of 3.4 for people with a job and a mean of 3.78 for people without a job, if in fact the null is true. Essentially, this tells us that we have a statistically significant relationship based on these 50, looks like I've got 53 people. Based on these 53 people, I can reject the null hypothesis. It says there's no difference in the population because my significance is lower than my alpha. That's what this small value means. That this mean difference between the people without a job and the people with a job is what we call statistically significant. It's legit. At least I can assume that it's legit. I can reject the null hypothesis that says there's no difference between them and conclude that these data support the assertion that those who have a job are actually going to have a lower GPA compared to those who don't have a job. Now, I don't know if it's cause and effect. Certainly, I can't speak to that, but these data do seem to suggest that those students who have the luxury of not having to work do in fact have a higher GPA. I don't know if it's a cause and effect relationship, who knows, but certainly that's what the data seems to suggest, that there's a statistically significant relationship between whether or not you have a job and your GPA. Those who have a job have a lower GPA compared to those who don't, at least on average and in general. And I know this because my p-value is less than alpha. And also, if I look over here at the confidence interval, I can see that my confidence interval does not contain 0, which again is the null value when you're doing a confidence interval for the mean difference, which is what PSPP has provided us here, the confidence interval, the mean difference. And so the null says that there's no difference, that the difference would be 0. And because the confidence interval doesn't contain this value, once again, we know that we can reject the null hypothesis, which says the difference will be 0. So there's 2 ways to know to reject the null hypothesis. You can be 95% confident that the true mean difference between people who have a job and those who don't in terms of GPA is somewhere between 0.1 and 0.66, so not 0. And again, I know this also because the p is small. There is a less than 1% chance, p equals 0.008, that I saw this data up here simply due to chance. That is how I can interpret this value. And that is how you can use PSPP to conduct a one-sample t-test or an independent samples t-test. Thanks again for watching, and I hope to see you in our next video.